Today we're going to look at using the area rule. You are required to know the proof of this rule for your matric exam. Firstly, what the area rule states is that in any triangle ABC, so this is the first time we've seen some trigonometry come into non-right angle triangles. So in any triangle ABC, the area is given by the formula a half AB sine C. Now it's important to notice here that these are small a and b over here, and a capital C. So we need to know, well, what is the difference between the small letters and the capital letters? Remember, vertices, now those are the corners of the triangle, so the 3 points. Vertices are always labeled with capital letters, and they refer to angle A, angle B, and angle C. Directly opposite angle A, the side is called little a. So instead of having to label the side BC, we can also label it little a. Opposite angle B is side little b, and opposite angle C is side little c or AB. Notice that the two sides here, A and B, go with angle C, which is between those two sides. We call angle C the included angle. So it's included between sides A and B. If I switch my formula, because I know angle B and not angle C, then the two sides here would have to be A and C, and if I put angle A over there, then my two sides here would have to be B and C. Right, so let's look at some basic examples. Here we have triangle ABC, where we are given that AC, or little b, is 7 centimeters, BC, or little a, is 6 centimeters, and angle C is 27,6 degrees. They ask me to find the area of the triangle. So I need to think now, well, I'm given angle C, I'm given little a and little b. So my formula is going to be area is equal to a half little a, little b, sine C. So using the sides that I've got. Obviously now it's just substitution. We've got little side A over there, which is 6 centimeters, little side B, which is 7, times by sine of 27,6 degrees. That's my angle over there. You really just plug that into your calculator as you read it, and you get 9,73 centimeters squared because it's area. Okay, very basic, using the formula exactly the way I gave it to you. In the second example, also really straightforward, but this time we're given different letters just so that you can see what's going on. Well, in this case, we're given little side D, little side F, and the included angle, in other words, the angle between little d and little f, which is angle E. That means that my area, so area, triangle DEF. Now think about this. I want to use angle E, so I want to end with sine E. That means I need little d and little f to go over here. Now really I'm working backwards here, but you'll get the idea. But the formula is a half. So it's a half little d, little f, and sine E. Again, it's just straight substitution. So little d is 29 millimeters. Little f is 54 millimeters. Don't put the units in the middle of your calculation. It'll just confuse life. And it's sine 61 degrees. Again, plugging that straight into my calculator, 684,83, and because it's area, it's millimeters squared. Voila. My last example is working backwards, and this time we haven't given you a picture, so we can just talk through things. But it says find two possible values, two possible sizes or values for angle X. Now that seems a bit weird, because that means we've got two possible triangles. Don't get scared before you start the problem. Throw yourself in, use what you know, and see what you come out with. So let's always just draw ourselves a picture so we can see what's going on. Well, we've got a triangle XYZ. Don't worry about accuracy. It's really irrelevant. No one's marking you on that. Little x, so that's opposite capital X, is 80. little y, so that's opposite big Y, is 150, and they asked me to find z. Now z is the angle between the two sides. It's the included angle. So they also give me the area. So we're thinking, well, hold on, I've got two sides, I'm looking for the included angle, I know the area. This links me to my area rule. We know that area is a half little x, little y, sine z. That means, let's just start with the half this time, a half times little x times little y times sine z, which we don't know, equals 3,100 centimeters squared. Now what we're going to do is just simplify the half times 80 times 150, and that gives me 6,000. So we've got 6,000 sine z equal to 3,100. This is now just a straightforward trig equation where you're solving for the angle. So we're going to divide both sides by 6,000, so sine z is 3,100 over 6,000. That goes down to 31 over 60. Don't write this like this in an exam, rather go to the next line. Remember, when you are looking to find an angle, you need to press Shift sign on your calculator. Shift sign when you're looking for an angle. This will always give you an acute angle. So if you type in Shift sign and 31 over 60, you're going to get 31,1 degrees. Now remember, back to trig equations, that is my reference angle. Because you've got sine z equal to a positive over here, it means that I actually have two possible answers, quadrant 1 and quadrant 2. Now, in trig formula, in this section, when you're looking at a triangle, it's possible to have either an acute angle, in other words, quad 1 between 0 and 90, or an obtuse angle, that's quad 2 between 90 and 180, within a triangle. Obviously, we can never have angles in quad 3 or quad 4 being in a triangle, because a triangle can't have an angle bigger than 180. So we're going to get a reference angle of 31, 1, and then understand that angle Z can either be 31,1 degrees or 180 minus 31,1 degrees. So it can be acute or obtuse, and we know that because over here there's an invisible plus sign telling me that sine Z is positive. All right, so that's the basics. You need to practice. Good luck.